All right. So I think we already have a critical mass. I think let's get started. So first of all, everyone, it's a pleasure to be here. Yolan, it's a pleasure to co-present next to you. This webinar is it's a bit of an experiment. We're doing it in a little different format. Usually we have webinars that, much rarer, and it's always like with some kind of, let's call it more academic topic. And then we try to demonstrate it and show it through a Deepchecks platform. In this webinar, what we're going to do is we're going to just be telling about the system, showing the system, and it's much more direct in the ability to ask questions, to get to continue with a private demo, and it's just like an alternative for having, let's call it, one-on-one kind of meetings. So I think that's the high level kind of context setting. So in that case, I really feel much more free than usually than in other events to interrupt a lot more, because imagine it's like a private demo for you. That's kind of the way it's supposed to feel. All right. And Okay, so I'll start off by showing a few slides, and then of course the most interesting part is Yaron's demo. So at Deepchecks we're building what we'll call the trust layer for Gen AI. Now you may be thinking, why do I need a trust layer, right? So the idea is there are many tools, sometimes called LLM ops, which we claim are a must-have to build. There are many tools that are needed, but I would say only some of them are what we call must-have. I don't think I said it right the first time. Out of the many tools that exist, I think only a few are must-have, and AI evaluation, which is our focus, is one of them. So you need a model, of course, not for every use case, but for many of them, you need a knowledge base, MCP tool, maybe a graph database, something external where you're getting data or tools or actions. And then, both of those I think exist. They're important, they're great, but I think, to some extent, I think AI evaluation, what we focus on, is the main area in which you still have 10x differences between different solutions and different approaches. Uh, so what do we do at Deepcheck's AI evaluation? So we have basically an entire platform that I can touch with many different areas, and we continue to add to it where it's supposed to be with you across the entire journey. So just to give a few examples, the one of our specialties is deep evaluation, where the idea is we have performance metrics. You'll see a lot of these. We have our own small language models named Orion. We have a multi-step, NLP judges that do each one looks at a specific property. We have some clients here that improved their app from like 33% accuracy to 85% accuracy. Now, the truth is, if you have a system that you know is 33% accurate, that's already a big step, and that's better than most companies. But then to get to the point where you can go drill down, dive in, and improve whatever's missing. So we have at least, a couple of clients where that's the main value they're getting out of the system, where they can see the nuances of what's broken and how to fix it. And then another field that we're dealing with is auto scoring. It has to do a bit with the deep evaluation, but we enable configuring a flow that's supposed to simulate a consistent and intelligent human annotator. And then this auto scoring is not just like one big LLM as a judge, but there's a nuanced approach that could take into account, business constraints, lingo, along with, internals, hallucinations, and so forth. So we have companies that are using this to create many versions of the same app, and then just choose which one's the best and start doubling down on those, even though we like to say that Gen AI doesn't have a test set. And now, maybe the last area that I just want to highlight about what we give, you'll notice during your own demo that it's built both for coders and for clickers. So try to enable, even when the technical team knows exactly what to fix, this trust layer we enable showing management and showing, we have companies where this is the main value that they're getting out of the system, where they're enabling to loop in an analyst or, like a business analyst, product manager, a senior executive, to be able to have them buy in, trust, and sometimes provide their very concrete input about the evaluation process. So with Deepchecks, you can sleep well. There are a few different areas where we can measure value, but they're all dramatic. I love this metric of that we the fact that we see customers of ours that are they're comparing many more versions than typical in LLM flows. You might have companies that have 100 different versions. They're just looking at the top few, and it kind of gave a high level of how you can do that. We have we see across the board, we see a decrease in hallucinations, low quality responses, by this iterative process of seeing what's broken and fixing it, and we have a much shorter time to production for projects that started without having Deepchecks implemented versus for the same companies. Once they have Deepchecks implemented, we see a major, major, major difference. So you might have heard the term LLM evaluation. I want to give at least, a couple of context, pieces of context. So how this uses the same name, LLM evaluation, but the flow is completely different. So part of what we're doing is the ability to start immediately. We build feature after feature after feature where you can, start from just, adding instrumentation to a system. And we have, pre-built auto scorings with templates per task type and so forth. And we're now working on a project called Know Your Agent, which enables giving, very, very hands-off approach for showing everything that does and doesn't work with your agent or chatbot and so forth. So aside from start immediately, there's a whole other area which is start right. So we kind of force methodology down your throat. I'll put it that way. Instead of once you have a team that's working with Deepchecks, it's an entire framework that uses state-of-the-art evals that we have that are proprietary, along with the ability to really quickly build judges, iterate, have an eval platform, and the flagship part of this one is something that we call the swarm of agents, where we're simulating the annotator. We have many of the agents working together. Now we have the ability to iterate quickly, so we're comparing versions auto improve the pipeline. We will automatically float what are the issues with different versions and what to improve, and then maintain control is just the ability to debug. We have automatically, analyze failures and have the whole flow of whenever you want to do root cause analysis, see what an issue was, why something deteriorated, or why it's not good enough to deploy. Then we have a very UI focused way of doing all this, where not everything's with code. So I'll just show one piece. This could have been part of the demo that Yaron's going to do. I just want to give a little bit of a technical explanation for what you'll see in Yaron. Remember when I talked about the swarm of agents technique? I want you to understand how this works. So instead of shoving all these evals to like an LLM as a judge to determine what's good and what isn't good, which we found does not work well when you have a few different constraints, which is actually the most common case. So what we've learned is that if we have many, many different judges where each one is in charge of just one split, it works much better. So we have the ability where you say, is the answer available? Like in this chatbot use case, did it avoid giving an answer? And then, if it avoided, which is no, the answer is not available, then we have another split. Can the answer be found somewhere else? So this whole flow where only then we determine if something's thumbs up, thumbs down. This is how we enable to mix all these proprietary models that Yaron's gonna show in the system, along with the logic that simulates what a human does. And this is very similar to having a policy set by yourself. So that's the high level about the system. And let's move over to Yaron to see hands-on.
Great. Thanks, Philip. Great pitch. I want, where do you buy? Uh, Thanks. Okay. So, hi everyone. I'm Yaron, head of product at Deepchecks. And together, we'll do a short demonstration of Deepchecks LLM evaluation. What we'll do is show a use case and go over, I would say, all core features and basic flows that Deepchecks LLM evaluation enables. Deepcheck supports a lot of use cases, RAG use cases, summarization use cases, chat, or classification. Today, what we'll see together is an agentic use case, which is really cool. I do want to lay some foundation and just talk about a few basic, I would say, terminology in the Deepcheck system. So first of all, one thing you need to know, organization would be any company, customer. In this case, you'll see the Deepcheck's demo organization. Each organization, each customer of ours has a few applications. Application is a project, a product that they want to evaluate. For example, an AI chatbot, or again, some agentic application, agentic-based application. Each application would have a few versions. Philip talked about that in his intro, and we encourage our customers to upload as many versions and compare as many versions as they can until they get to the required results. Oh, so that's organization, application, and version. Within each version, there are sessions and interactions, which are equivalent to, I would say, traces and spans. So I believe no need to elaborate on those, but single interactions with the LLM or with other components of of the application. And each interaction would have what we call an interaction type. This is important for the demo itself. Each interaction type or each interaction again has an interaction type, which is a sort of a configuration that determines which properties, which metrics we check for that interaction. So, for example, an LLM interaction, an LLM span would have a certain configuration, certain metrics that we want to check for that span. And retrieval span or retrieval interaction might have other metrics, other properties that we check. So interaction type is a configuration. And some two other things that you should know is system metrics, latency tokens, stuff like that, that we get automatically from the pipeline when uploading the data. And properties, quality properties are what we call, I would say, quality metrics, which we on Deepchecks calculate for our customers per each interaction and session. So I would say that's the very basic terminology that everyone here we should be aligned on before deep diving into the demo. Okay, I'll share my screen. Philip, just tell me that you can see it right now.
Yes.
Okay, great. So what you see in front of you, we won't go over the whole code here, but what you see in front of you is a content creator agent built with CrewAI. So as I said, we support agentic use cases. We have a few great integrations with agent building frameworks. One of them is CrewAI. So this example is from CrewAI. What we see here, and we won't go over the whole thing, but what we see here is a crew that has, and I'll assume that some of you know a bit about CrewAI at least. It's a crew of agents, a group of agents that work together. In this case, this crew has three agents. They together are supposed to create content, like a blog post. One of them, as you can see here, would be the writer. Then it passes its outputs to a reviewer, which in his turn passes it to the editor, who has some editor tools in order to produce together to produce the best blog post that they can. So these are the three agents that work in sort of a workflow. Each of them has some tools that were configured earlier. We won't go into that because the main purpose of this demo isn't to go over how to build agents with CrewAI. The important thing that you need to know about this code is that I only needed to add these, I would say, 5 or 6 lines of code in order to install one package in order to upload to automatically log all the traces that the runs of this CrewAI application produces. So
You
I
could,
would run this application.
I'll just jump in here and say, even if you would have seen the demo of Deepchecks 5 or 6 months ago, it was not like this. Like you could have gotten some of the value, but you'd have to do, there was a lot of work to be able to send all this data to Deepchecks. And it's amazing to see the difference.
Yeah, great. Thanks, Philip. So all I had to do here is again add the Deepchecks host, my API key to Deepchecks, the customer's API key to Deepchecks, the application name and the version name, and during the run, all the traces, all the spans of the trace would be automatically logged into Deepchecks. Now, before showing you the logged traces in Deepchecks, I would say, and we did upload. You'll have to believe me. Earlier today I uploaded a run of a batch of a few queries, a few inputs to this crew. I'll show you them in a second. I will say that most of our customers, those who don't currently have agentic applications, but have, I would say, more classic use cases like RAG use cases or summarization use cases, upload their data in other ways that we enable. One of them is uploading data via our UI, which is super straightforward and simple, and the other one is uploading via our SDK. Both of them are, I would say, super elaborated in our documentation on our site, so you can go there and see how exactly to upload via the UI or the SDK. Here is the third method via login traces. So I will show you how this is seen on Philip. You see the app, right?
Yes.
Great. So this is the version that I just uploaded, baseline cloud 3.5, which means I tried to run the crew with a few inputs, in this case, 31 sessions, 31 runs with different inputs using Claude 3.5 Sonnet. That was the model that I used. Now, let's start going over the core features of the application itself. So first of all, what you can see here is we enable deep diving into the single session or the single trace in this case both for observability and for evaluation. So what you can see here, I'll just close these collapses for a second, is a signal trace. Okay, this is the root, this is the whole trace. Three agents, the content writer, the content reviewer, and the content editor. We can open each one up and see exactly what spans they were built from. You can see the hierarchy, exactly who's under who and who triggered who, which span triggered which span. You can see the interaction types that we just talked about that, again, we parse automatically. So in this case, this is the agent. This is a completion is an LLM span. Then it passes the data with a request to a hook improver, which is a tool. So it's amazing how you can see what visibility you have to your pipeline, to the run. You have your system metrics, in this case, latency and tokens of each span, and latency and tokens of the whole trace. The data fields right here in the middle, including the raw attributes that we got from the log traces. And what you see here on the right are the properties that we calculated. Now, these happen very quickly. From the moment I uploaded these 30 sessions, I got the data is uploaded automatically. You can see them within a second. And the properties, the metrics, the quality metrics, probably within a few 2-3 minutes, you get all of these properties for the whole pipe for the whole 30 sessions. So in this case, what I want to show in
Just Johan, I'll stop you for 1 second.
no problem.
We have some folks that joined in the middle, so anyone that feels free, please introduce yourself in the chat. Try to say where you're from, what you're working on in the context of LLMs. It's always funner to kind of know who we're talking to. All right, continue, Johan.
Great, thanks. Here in the properties, all of these properties are research-backed, state-of-the-art, great properties. Some of them are GPU-based properties, small language model that we trained. Some of them are LLM-based, but again, research-backed with prompts and models that we configured. And for each one, you can see the score from, I would say, 1 to 5 in this case, see the reasoning. So in this case, this interaction has, this whole trace has high completeness. With the reason, I won't go into the reason now, but just to show you great visibility into the evaluations too. And the last thing I wanted to show you here on this screen, on the single session screen, is the auto annotation that Philip talked about before. So in this case, I won't get into it again because Philip talked about it in the intro. But for the folks who weren't here in the beginning, this whole session, interaction, the root interaction, was annotated as good due to properties and the auto annotation configuration that this root interaction has. But if we go to, let's say, a bad interaction. So this is a bad agent. It got annotated as bad. And again, if we can see that it was annotated as bad and see exactly the reason why. So in this case, low tool coverage. I can go into tool coverage, this property, which is a built-in property, and understand exactly why tool coverage was low and why this whole interaction was annotated as low. So very, very easy to understand the single trace and why I got a good or bad annotation for the trace. So I would say that's enough for a deep diving into the single session. I want to show one more thing regarding the properties. So what we saw until now is built-in properties that we at Deepchecks built for our customers for different use cases. What a lot of our customers do, because each one has their own use case with we need to do some tailored properties for the use cases, we have an amazing ability to easily create custom properties. So this is how you add a property. But in this case, I don't want to add one of our built-in properties. I want to add a custom property. So I'll add a custom property. I want to add, let's say, a categorical property. We have two options, a categorical property or a numerical property. A numerical would give us a score from, let's say, 1 to 5. A categorical property would assign the property into categories. So let's say I want to create a categorical property. I already ran this before, so I'll show you the results in a second, but I would call it, let's say, seriousness. Okay. Two categories. One is serious. The other one is, I won't give the instructions now, even though it would be probably better. Let's say unserious would be the second one. I'd save the categories. It would work on the output of the agent. And I would give guidelines, assign to serious if the output sounds serious. Otherwise, assign to unserious. Now we have a really cool feature because this is very basic guidelines, probably not the best prompt. We have an amazing feature called optimize, which within seconds would give me a great prompt that would actually do what I requested. I won't go over it now, but evaluate overall tone, detect humor, etc., etc. Done. It gets saved into my guidelines. I can even test it on a single interaction. So let's test it, for example, for this interaction. This test gave this interaction, assigned it to, let's say which category. I would say serious. Yes, serious based on the output. Then I would save it. So I won't save it now because believe me, I already did it before. I'll just show you the results. And once I go into interactions, which is the list of interactions, if I want to inspect all the agent interactions of this run, I would have I can see all the interactions. I can see a few fields. I will ask to see seriousness, and then I see for each interaction which one was serious, which one wasn't. I can sort based on the different categories, and I can even filter. Here I am adding a filter. Let's say I want to filter only based on seriousness. So I go into the filter and I can filter, give me only the unserious interactions agent. So this is great, very, very easy to create custom properties to make them work both on only future data or run them back on older data that I have and then use it for filtering, for inspecting data. So this is the interaction screen. And there is one more thing I want to show you I would say one more drill down into analyzing my version. Until now, we saw the single interaction and the list of interactions. Now, let's say I want to understand the whole performance and the holistic performance of my version. So I have the overview screen, which gives us this holistic view, and it has a few components. So first of all, you can see here for each interaction type, so for all agents, for all LLM interactions, all tools, you can see the different general score. So in this case, the agent got a score of 78. The score is calculated based on the auto annotation of each agent interaction. So 78% of our agent interactions were annotated as good, whereas 22%, 20 interactions were annotated as bad. Let's say this isn't good enough for me. What can I do? So we have a few components to do to perform root cause analysis. I will talk about three right here. The first one, show score breakdown. This gives me the list of reasons of why, let's say, the agent interactions were annotated as bad. What I can see here that 20 interactions, let's say all agent interactions that were bad, failed on tool coverage. So I probably have a severe problem with tool coverage. We'll see it in a second. After I see that, after a customer sees that they have a problem with tool coverage, they can go into the agent insights and they see that they do actually have, and this is Deepchecks, again, research-backed and generated built-in insights. So we produced an insight of insufficient tool information, which you can exactly read here why exactly this was produced, and then click on view the data to see exactly the interactions that were bad, that fell on insufficient tool information. And I won't do this now because you already saw this on the interaction screen. And the last, and I would say coolest feature that we have for root cause analysis would be the analyze property failures. So our customer already understood in this case that they have a problem with tool coverage. They just don't exactly know what the problem is and how to mitigate it. So they can click analyze property failures. They choose, in this case, tool coverage, which they know is the major problem. Verify that the version they want to check on and the environment is the correct ones, and then generate a summary. They can even add here some additional guidelines. They want us to focus on a certain aspect when generating the summary, and then they can generate the summary. Once they generate the summary, it takes a few seconds, and our customer gets a high-level free text summary of what exactly is wrong with why exactly tool coverage was a severe problem. So in this case, we have a few categories, 1, 2, 3, 5, 6 different categories. I'll go over one of them. So category 1, they're missing core output due to tool limitations or errors. Okay, so we're missing core output. We'll read the description. The failure type involves cases where LLM, et cetera, et cetera. And we get three, even more sometimes example. I would say the main examples that show, that demonstrate this category. So we can click the example, and this example that we'll see in a second, strong supporting content is retrieved, but the main output, the blog post itself, is missing, which is why we have a problem with the tool. I'll click the example, and it opens a new screen of the specific session, the specific interaction that had this problem with tool coverage. I can go into its specific reasoning and drill down, analyze it further. And after this, I'll probably understand exactly what's wrong with my tool coverage and fix it. So this is what I wanted to show about the single versions. Single version. Philip, any additions to this before I go into version comparison? You're on mute.
No, no, this was great. I think let's just do the let's try to conclude in a couple of minutes, and then I'll show
Great.
you how to read.
Great. Okay.
In the meantime,
Sound.
I think there are, people here from all around the world, and each one has a different use case. I know in these kind of demos, then it's you always get a more generic explanation. But first of all, feel free to ask questions here. Second of all, we could also do a private session when you give more about the context and use cases, and when you can talk out loud. That's also helpful. So let's do the version comparison part, and then I'll kind of show. I'll give some.
Okay.
What could next steps be for anyone that's interested?
Sounds great. So I'll talk about the last part of our flow, of our basic flow, last core feature, which is a version comparison. So I went back into my code and I uploaded three other versions. The first version was a version that I changed the prompts according to the problems I found and fixed in tool coverage. I already did this earlier today. And then two more versions that worked with other models. Um, and then I uploaded all of them to Deepchecks. Same inputs, okay? All of them have 31 sessions. So you have the baseline Cloud 3.5 Sonnet, which we all just saw. We have the enhanced Cloud 3.5 Sonnet, which is the 3.5 Sonnet run with the better prompts. And then two more, Cloud 3.7 Sonnet and Nova Micro. So if we go into the version screen, we will see all these versions one next to each other with Deepchecks enabling us to very easily compare them high level. So what you can see here, first of all, you can see, and I'll sort by score, you can see which one is best according to annotated interactions. In this case, agents. So of course, Cloud 3.7 Sonnet, sorry, has 95% accuracy, which means quality of 95% of the agents. Well, the first baseline that we uploaded before mitigating what we needed to fix had only 78%. And after we fixed 88%. So Cloud 3.7 Sonnet was obviously the best. We can check specific properties if we want to compare. And we can also add, for example, if we're very interested in, and most customers are, in latency and tokens, we can also add those to the picture. So what I can do here, I can see that Cloud 3.7 Sonnet is the best, but on average, it takes around 10 seconds more than our baseline Cloud 3.5 Sonnet, and it costs more than X2 or about X2 tokens, and about X2 dollars probably. So this helps me a lot with understanding what would be the best model for me, the best version, not just the best model, the best version of my pipeline for me based on general score, different properties, latency, tokens, and other. So this is amazing, and we see our customers using this a lot. As Philip said in the beginning, uploading a lot of versions and then picking the best one that answers the requirements. I guess this would be the last core feature that I wanted to speak about. And Philip, I would hand it back to you now.
All right. So just one second. Maybe you stop sharing and I'll start sharing. All right. So thank you so much, Yoan, for the more interesting part of this event or this demo. Now, I just want to state we have multiple deployment options. As I hope you saw from Yoan, this is extremely, extremely, extremely different from doing kind of internal LLM as a judge from with, everything has to do with start immediately, start right. You're getting, auto tuning of your prompts and insights about what's not working and version comparisons. It's completely different. And of course, this comes with heavy infra. So we have a SaaS platform you can work with. We have on-prem deployments, and we have the ability to work within AWS for whoever it's relevant for. where it's in your account, not our account. We have a very unique partnership with the AWS team. So I think maybe just to give a context for what it looks like when you want to, check Deepchecks out. So we start off with a kind of alignment call, kind of choosing which plan, which deployment we'll have if we do end up collaborating. And then you have some sort of minimal homework on the client side on just determining which data you want to have and have an expert review on it. For giving a specific LLM map, then we'll extract a couple of inputs and outputs and we'll have a free review of the data on our end. It will show issues with it. Then we'll do a pipeline audit and put everything in the system and with a kind of white glove implementation, show you what are the issues we found, what does it look like when you'll fully continue to do the to set up the auto score for your use case, and then we provide trial access to the system that we deployed. So this is just to kind of make it a lot clearer what it looks like. And of course, we can't have the individual discussions with each one of you for what it could feel like, but the I think maybe just as a very clear next step. So first of all, we'll reach out after the webinar with with just some follow-up details. But you could either reach out to me by mail, Philip Philip at deepchecks.com, or to info@deepchecks.com, and we'll be happy to explore this together. And this is our motto: with great AI comes great responsibility. All right. One second. I see one question by anonymous attendee. Looks great tool to extract data, validate data sets, but what is the difference between confidence, Ryan, distiller? I'm not sure I got the question, to be honest. Did you get that, Johan? All right.
No, didn't understand the question exactly.
I think it's much better to do this in a one-on-one session. So anonymous attendee, whoever you are, reach out if it passes a certain threshold of interest. All right. So in any case, I think this was a great combination between not being too long, but also going pretty thoroughly between all of our main features. And there are a lot more interesting features to come. So thank you so much for joining us, and highly appreciate it. Yaron.
Bye, everyone. Thanks, Philip. It was great.
Thanks everyone, and we'll be in touch.